So my question is like, why is my video not widescreen? Did I break it? Did I do something? Yeah, that's what happened. Cool. So we are here today to discuss the final project, which I am going to share my screen. Desktop 2. Share. Okay, it's recording. All right. Our good old friend, the backend curriculum site. We are in module 1. I'm going to get the projects, and it is Enigma. Enigma is a project named after one of the things that Alan Turing, what school is named after, worked on. So essentially, if you don't know, the Enigma machine was a mechanical computer made, not a mechanical computer. Essentially, it was a code set used by the German Navy in World War II, and Alan Turing was a team of scientists that broke the code, helping the Allies win World War II. And the idea here is that this project is a kind of a code-breaking, code-generating program. You all did the Caesar cipher during the pre-work, yes? The Enigma works similar. And so this project is going to have like 3 phases to it. What I suggest doing is that the first thing you should do is grab a piece of paper and work out the encryption algorithm on your own, just using pen, pencil, or whatever, and paper. So you really understand how it works outside of a code sense. Because if you don't really get how it works outside of your computer, you're not going to be able to, it's going to be much more difficult to get everything to work. So the idea is that this application, at its core, you'll make a file on your computer with plain text. Plain text is what I would describe as undeciphered text, like a hello world, whatever. Your application will essentially read this file, look at the date, and using the date and the encryption system, create ciphertext. And ciphertext is the jumbled, scrambled message, and it will then write that out to your disk. That is kind of like one phase of it. The second phase is that essentially, how useful are codes if you can't read the message that you've coded, right? So there's got to be a round trip, right? And so you're going to read in a file that's ciphertext, and you are going to be able to go in the reverse direction. And finally, there is going to be a thing like, what do you do if you, how can we essentially hack a code? Like if you don't have the thing. So let me kind of walk through the algorithm. So this idea is that the encryption algorithm we're going to use is going to be relatively pretty simple. It's going to be based around the Caesar cipher. And essentially the Caesar cipher is a rotational cipher in that we transpose a letter a certain number of characters. So like, let's say, for example, if our key was 2, every letter would be moved 2 up. So like A would be C, F would be H. Am I right? Sure, we'll just say H. It's 2 over, right? And so forth. And that's very simple. And the thing is that, like, how secure do you think that code is? Well, like, the idea is that we could just run our code through the 26 different possibilities, right? It can only be shifted over 26 times, and the one that came out looking like English or whatever language is going to be the one we've got the code. So the idea is that we're going to shift by different numbers, and so each shift that we're going to do is going to consist of 2 things: the key and the offset. So the A shift will be the A key plus the A offset. The B shift will be the B key plus the B offset. So the key, if you look here, you can see here that the keys are used by generating a random 5-digit number. For example, 02715. And the A key is the first 2 digits, the B key, second and third, C key, third and fourth, D key, fourth and fifth, right? So those are your keys. The offsets are shifted by the date. So like if the day is also 495, it would be this. And using the last 4 digits of the squared of the date, you determine your offsets. Your A offset is 1, second offset is 0, third offset is 2, the fourth offset is 5. You take the offsets, you take the shift, you take the key, you put them together. That's what you're shifting every single letter in your code back. And because there's only 4 of them, how that works for like like paragraphs of text is that, let's say we have hello world. H is going to be shifted by the A key plus offset, E by the B, L by the C, the second L by the D, and for the O, which is the 5th letter, we go back to A. Everyone found, hey, be cool. Right, so we go back forth and we just kind of repeat that process throughout the entire thing. So that leads us to the ideas that we encrypt this word, and this notes here are going to like kind of go through the whole thing. And the thing is that when we encrypt, the key is generated for us, and it's going to generate the thing. It'll tell us what the key is. And we also presume that we know the date. And when we decrypt, we are giving the application like, hey, I want to decrypt this message. This is my key, because you should know the key if you want to decrypt it. And this is the date of the message. So we have these 2 informations. With that 2 information, we should be able to go in the reverse direction. However, the third part, which is the fun part, is that we also want you to crack the code. So we want you to be able to decrypt a message without the key. There are a couple approaches to do this, but that is probably going to be the most fun, most interesting part of it, is how you go that route. Any questions so far?
Are these split up into iterations?
Nope. Like there are no formal iterations, but I think that would be described like, well, getting it to encode is going to be the first step. Getting it to decode is the second, and getting it to crack is the third. So those are like logical things, logical ways you can break that up. Cool. And again, I really want to stress that after we're all done here, take the time to like write out your name and encode your name and decode the name. Make sure that you understand how this algorithm works based on paper and pencil before you start writing code, because that's going to because we don't want you to get like halfway through the project and realize all of a sudden that there is some kind of fundamental misunderstanding of how the encryption works. Cool.
Can I add real quick? Sorry.
Sure.
I think you said I think you said crack was the iteration 3 is kind of how they can think about it.
Yeah.
I think on the rubric, the cracking method is for a 4. So it's just encrypt and decrypt for a 3.
Yeah. Yes. But please get to the crack, because that's like the most fun part. I'm not lying. That is literally pretty fun to do that. Cool. Yep, that's encrypt. Cool. Let's see, what are the questions? Submission. Yeah. I think that this is going to be something that's also new to you, is that before you're done, before the due date, we would like you to self-assess your project and write that up in the README. And that's right here. This is an individual project. You should not be working on this with other people, not your mentors, and not Krista. You can talk about it in general terms, but not like really sharing code. If there are specific code related questions you have, DM us with it. Any questions about that? Anything else that's not related to the project you want to ask? Meg, do you have anything else you want to add? Is Kat in
No.
here? Does Kat have anything else she wants to add?
Yes and no. The cat's in
mean-
here and no, she doesn't have anything to add.
Okay. I thought you weren't sure if you had something to add or not. Cool. But that is it. Goodbye.